Hello, I'm Garni Barkajarian of the Pacific Neuroscience Institute and CNS member for more than 10 years. What I love most about being a member is access to cutting-edge science and the opportunities that have advanced my career. I've also gained new colleagues and lifelong friends. Being a CNS member has been so rewarding. The value of membership cannot be defined by a number. Join me and the over 10,000 neurosurgeons who are making a difference in the world. Visit cns.org/membership podcast today.
Hello, everyone. Welcome to the September edition of the CNS Journal Club podcast. My name is Jeffrey Traylor, and I am a resident at UT Southwestern Medical Center, and I'll be the moderator for today's discussion. Today, we'll be talking about the article, Robustness of Randomized Control Trials Supporting Current Neurosurgery Guidelines. And I'll start by introducing the author and some of the guest faculty. Dr. Zinn, would you mind introducing yourself for everyone?
Yeah, my name is Pascal Zinn. I'm one of the brain tumor and spine tumor faculty at UPMC, and really, great you guys invited me here to talk about our paper. Credit goes really to Farouk, the brilliant postdoc who did most of the work.
Of course, thank you. And today we're joined by guest faculty, Dr. Nader Pouratian. Dr. Pouratian, would you mind introducing yourself for us?
Great, thanks for including me. Nader Pouratian, I'm professor and chair of neurosurgery at UT Southwestern, but also possibly relevant to this discussion, I was the previous chair of the guidelines committee for the CNS, so I read this article with great interest. I think guidelines are critical to our clinical practice, so understanding what affects our outcomes is, or our interpretations is really critical. So looking forward to this.
Fantastic. Thank you so much. And then Dr. Huang, I think most of our listeners are familiar with you at this point, but would you mind introducing yourself for us?
Sure. I'm Kimberly Huang, and I'm at Emory University. I have a practice primarily in tumors. It's good to see everyone again.
Thank you so much. All right. Well, Dr. Zinn, to start us off, would you mind just giving us a brief overview of your article for us?
Yeah, of course. So I think this is really important work in a way because it's a new angle in terms of metrics for clinical trials. We're not very familiar with a robustness metric beyond what we usually know how to interpret somewhat, or we thought we would know, meaning p-value, confidence intervals, like number needing to treat, and so on. So ultimately it occurred to us that I think most people probably don't understand those metrics. What does it tell you when a p-value is 0.0005? How do you interpret what that actually means if you're not a master statistician? And what is the confidence interval? What is the power of a trial? These are all metrics that probably most of us, I would say, don't actually know what it means in terms of what does it mean for the patient and the number of patients needed to reach significance. So we were, I was intrigued when Farouk came to me. We talked about the idea of measuring robustness and applying a known entity such as the fragility index to the neurosurgical literature and guidelines. So fragility index, or robustness of clinical trials, this was already described in the 1990s. So really, quite some time ago, and it has been applied to some of the fields outside of neurosurgery, but really it hasn't gained any traction within our field. So what we set out to do is we just wanted to start with neurosurgical guidelines that are based on papers that are reported on CNS-AANS websites. And out of about 312 RCTs that are listed there, we ultimately were able to extract this metric, fragility index, from about 120 studies. And the paper discusses those metrics. It's important to know what the fragility index is, or the robustness of clinical trials. It's really, it's interesting. It's ultimately, kind of easy to understand, I would say. So FI, or fragility index, is the number of patients needed that need to flip from a event to a non-event arm, meaning if a patient is in the experimental group in the randomized trial, let's say there is 100 patients in the experimental group, and let's say there is, of those patients, let's say 50 reach endpoint and 50 don't reach it. And if you increase then the number of patients that reach the endpoint by 1, meaning 51, and then in the other arm there is 49. You do this until you flip the significance essentially, or you invalidate the trial. So in other words, FI is the number of patients that need to be flipped between the two arms and moved from one arm to another arm to invalidate the trial. And some of those numbers are alarmingly low, meaning if the fragility index is low, it means that very few patients need to be flipped to invalidate the trial. And I think the main takeaway from the paper is that across all the trials analyzed, we have a median of 7 patients across all those trials that make up our current guidelines that need to be flipped to invalidate those trials. And what is even more alarming, I would say, is that some trials don't report patients lost to follow-up. So we came up with this metric, and we alluded to that in the article, that in fact, measuring the fragility index, meaning the patients that need to flip to invalidate the trial, minus perhaps the patients lost to follow-up, could be really a novel metric for robustness. Think about it. Let's say a trial has 200 patients and 5 need to flip to invalidate the trial, meaning an FI of 5 for that trial with 200 patients. But there's perhaps 10 patients that were lost to follow-up. So think about it. If 10 patients are lost to follow-up, but it only needed 5 to flip, I think it's really up in the air what the trial significance overall is. And another important finding, I think, that we report in this article is that the fragility index over time does increase. So the trials are becoming more robust, particularly since 2010. And I think really that's sort of the main message of this. At this point, we're working on a follow-up trial focusing on mostly neuro-oncology trials and Kaplan-Meier curves, and we're ready to report those results soon. And as well, interesting findings, of course. So I think more and more studies will apply this perhaps to the neurosurgical literature.
Thank you very much for that summary. I think that we can start with a discussion with some of our guests here. Dr. Pouratian, do you have any questions for Dr. Zinn about that?
Yeah, I think it's a really interesting concept. And as you mentioned, it's new to our field of neurosurgery. I want us to maybe try and make more sense of what these values actually mean. And I have, I guess, 2 somewhat related questions. But first, I think, based on the discussion, our number of 7 actually is pretty good compared to other fields, right? Can you comment on how we're performing, compared to trauma, anesthesia, some sports surgery trials, and where we are in neurosurgery? And then I have another question about that as well.
Yeah, interestingly, as we mentioned also in the paper, there is no real cutoff reported what is a robust trial versus a non-robust trial based on FI. But certainly 7 seems to be slightly better than some of the, let's say, venous thromboembolism trials, some of the other surgical trials. Most of those trials report an FI from, between 2 and 5, but also don't report, for the most part, don't report their patients lost to follow-up. And another metric that is really important is, I would say, the percentage of FI over the entire patient population in the trial, which I think we kind of underreported in this paper. And it's something that perhaps matured kind of in our own views a little bit more, and we're going to report on that. But it is sometimes shocking that there can be, sometimes 500 patients in a trial, and it needs really like single-digit patients to flip to invalidate it. So meaning, sometimes less than 1% of patients, FI is like, less than 1% of the entire population. and that is kind of worrisome. But I would agree with you that there is much worse examples in the literature than what we found here. Yeah, and over time those improve. So that's hope. Also, I think that we're doing better and better.
Yeah, so you beat me to the next question, which was, I think an FI of 7, meaning 7 patients to flip from one to another in a trial of 20 patients, which some surgical trials can be that small, is very different than 7 patients out of a trial of 500 patients. And so I think denominating it seems like it would be valuable, right?
I absolutely agree. Yeah. Of course, in the FI calculation, the total number of patients is a part of. It's already accounted for, but I think it's important to report it. 1/3 of the trials that we analyzed had an FI of 3 or less, and then some trials that report patients lost to follow-up, like it can even essentially go into minus. If you have, let's say, an FI of 3, but you have 5 patients lost to follow-up, that's kind of a minus trial, which I think that's where it starts becoming a little bit worrisome, I would say.
Yeah, and I guess the other comment I'll make is, when we think about clinical trials, it is an interesting idea to think about, well, what if patients flipped and the loss to follow-up, which I think are outstanding points. But ideally, a clinical trial is setting up the hypothesis and testing in advance. So we have to have some confidence in our results. And, as you talked about power, it seems like there should be some consideration of the effect size also, because, having, again, let's just say 5 to 7 patients flip on a trial that only had a marginal effect size seems like it's a much bigger deal than 5 to 7 patients who had a significant effect size from whatever the intervention should be. So I don't know, how do you think we're ultimately going to consider all these different variables?
These are all great points, of course, and this paper is not the answer, to everything. It's just an additional metric, and we perhaps have too many metrics, but I think it's certainly a combination of everything. I do think, though, if we had a metric like, let's say, number needed to treat, right, is very intuitive. We need to do a carotid endarterectomy in so many patients to help, 1 patient. That's a number everybody understands. FI is a number everybody understands. So let's say in brain tumors, the interim analysis of the Optune trial. So this is all new data. This is unpublished now at this point, but we're going to come out with this paper. The interim analysis of the Optune trial had 315 patients, and an FI, as we calculated it, is actually between 1 and 2 patients. And the full analysis had 695 patients, I believe. And the FI went from between 1 and 2 to 9. So that really added robustness, still relatively low overall, but I think it's a metric that is very palpable to about anybody. And we understand, together with the p-value and the confidence interval, I think, what to make out of it. At least to me, it changed the way how I look at trials. Now I'm asking my postdoc the whole time, if a new trial comes out, hey, tell me please what the FI is for this trial. And he's going and calculates it. So it's an additional metric that I find very intuitive.
Absolutely, and I think it just emphasizes that we really shouldn't just be looking at the p-value and the result. We really have to look at the actual results and the interpretation and make sure that we make sense of it from a practical standpoint. If someone else wants to jump in and ask any questions.
Yeah, I was just going to say, Pascal, it's good. You could stir the pot as a tumor person for the Optune thing, just start around a little bit more for all the neurosurgical oncology, since there's so much controversy there. So go ahead. That was great. A great way to keep that conversation going. But I guess, we actually have 2 really good people to ask this question here, both Dr. Pouratian and Dr. Zinn. We talk about all these metrics now about how to evaluate clinical trials, and obviously a lot of us are on guidelines committees, and Dr. Pouratian was the former chair of, the guidelines for our field. And so, what metrics maybe looking forward, in your guys' opinion, should we really be focusing on? Is it FI? Should we keep doing the things we've been doing as we currently have to pick out the best trials? Is there a way we can improve our process? Those take a lot of work. And so I just want to maybe get your guys' thoughts on that situation.
I think we partially perhaps answered some of that question already by, it's never kind of black and white. It's always multifactorial, and none of those metrics are perfect by themselves. Like p-value is really, really flawed, right? And we all know from, like, let's say, large database analyses, let's say the SEER database, we published a paper, a couple of years back with like 20-some thousand patients in GBM. And, whatever you look at, any type of outcome, you have a p-value of 0.00000, whatever, a bunch more zeros and then a 1. So highly, highly significant, but maybe the survival difference is like, a couple days, right? So the higher number you have is not always better. Interestingly, we always think the higher powered something is, like, the more robust it is. It's perhaps more robust, but the result might be highly significant, but meaningless. So I'm just starting to understand somehow what those numbers mean. And if you look at the extremes, like in this example, like higher number, probably lower confidence interval, right? Less, variability because you have a higher N, is not necessarily better because it shows you something is significant that is meaningless.
I think I would follow on that, a lot of what we do in the guidelines committee is not just, as I said earlier, look at the abstract and results, but really look at the quality of the study, the design of the study, and the outcomes. And it's not just a matter, when we're developing guidelines, of looking at the results, but asking questions that are clinically pertinent and determining whether that RCT and its results move the needle in answering those questions. If you look at guidelines, it's not just a summary of RCTs. And so it is this, idea that we've all learned over time, that statistical significance doesn't equal clinical significance. And it seems like this FI, or fragility index, really sheds yet a different light on how we interpret these studies.
And I think it shows that over time, trials are becoming better as we're just more skilled, I think more collaborative in the digital era, kind of to, design multi-center trials that just include more patients, that run, in a more, I think, sound fashion, and with increasingly, experts involved, I would say.
Yeah, it was encouraging in your findings of your paper that, over time we've gotten better, right? So we haven't stayed stagnant in the quality of, at least with regard to FI, and hopefully as we've continued to refine our guidelines, which, to Dr. Pouratian's point, asking the right question for guidelines that's actually clinically relevant, which the leaders of the guidelines do, I think helps us as neurosurgeons a lot, for sure.
I also think design of the trial, as Dr. Pouratian mentioned, is extremely important, like expert design, analysis, and interpretation. And, we are experts, and we have to kind of give a value to a trial also, perhaps sometimes not directly related to those metric numbers, but also we have to balance it with our experience, and design is very important.
Absolutely, absolutely. Dr. Traylor, any questions from you?
Yeah, I wanted to follow up on something Dr. Pouratian said a little earlier in talking about how neurosurgery compares to other fields, but rather within neurosurgery. I know this study focused on cerebrovascular disease, neuro-oncology. Are there any subspecialties of neurosurgery that are more or less conducive to clinical trials? Are there some that are more susceptible to low fragility index?
Or spine is, a really big discipline in our field, and it hasn't really been applied to neurosurgery spine. I expect some of those trials have slightly more patients than vascular and tumor neurosurgery trials. So I expect FI to be somewhere, in a similar area to perhaps maybe slightly higher, depending on the trial. Actually, something else I wanted to mention also is we also were looking at, these are significant trials we looked at here. So we're also looking at trials that are non-significant. And interestingly, they also demonstrate, some non-significant trials demonstrate a very low FI. So there goes the thought, right? Like, had been less patients lost to follow-up in some of those trials, would they be significant? And with what FI? So it's just an interesting thought experiment to think about that. And we're analyzing that at this point. And that is just something I think. What I'm also interested in, and we don't have that data yet, is to compare FI averages for significant and non-significant trials. So that could tell you that I would expect a bell curve there. But if there is no bell curve, then we have to reconsider how those are analyzed. And perhaps there's some bias there with significant and non-significant trials that I'm curious to show.
Do we have any
Thank you.
idea? Sorry.
No, go ahead.
Do we have any idea through maybe the history of neurosurgery or in other medical subspecialties, whether studies with low FI are likely to be quote unquote debunked in subsequent trials or for practice to be changed? So does it have any prognostic value in terms of how robust the findings will be in terms of their impact on practice?
That's a great question. We have not looked into that.
Don't go write a paper now. That's my idea. You can't do that.
Well, we'll put you on the paper.
No.
We'll write it together. That I can say as much that we looked at, I think it's over 70 neuro-oncology trials now, because at the time of analysis for this paper, we were not able to extract FI from Kaplan-Meier curves. So this is a big limitation of this paper because it underrepresents the neuro-oncology trials clearly. This is heavily focused, I would say, on neurovascular neurosurgery. But we're able to actually, we developed a technique to extract FI from Kaplan-Meier curves, which also allows actually to publish meta-analyses from across all the Kaplan-Meier curve trials. So we're able to extract the primary data from, through a technique we developed, and we can publish meta-analysis of all those trials now. Like, we can just group it all together. And there's interesting, stuff coming out. But what I just, as an example, showed, the interim analysis had an extremely low FI, like of the Optune trial. And then it becomes more and more robust as it's matured and the final results are published. So I think based on the interim analysis of that example, one would just, thought the whole thing will be debunked, and then FI, goes quite significantly up. But as a comparison, like the Stoop trial, the 2005 trial, had an FI of 17. So that seems a little bit more robust than other trials.
Thank you. I had one other question I wanted to follow up with. You were talking about how after publishing this paper that you're calculating the FI for new trials that are coming out. It seems like that might be difficult for a neurosurgeon or a clinician of any kind reading these trials to do. Is there a shorthand way, or is there any sort of, you said that sample size didn't necessarily predict robustness there, but as we read these trials, what's a good takeaway for us to interpret them without going back and calculating that? Also,
in this paper, there were a lot of multi-center trials, very few single-center trials. So that data may not accurately reflect that relationship. But in our follow-up analysis, we clearly show that a higher sample size, national, multi-institutional trials tend to have a higher FI. So there is a relationship there. Well, what was your other question?
Oh, I wanted to follow up actually, since you bring that up. So was there an explanation for why the multi-institutional trials were more robust if sample size was not the predictor?
Actually, I think it ends up being a predictor, and we showed it in our follow-up study. This was just not significant. There was a trend
On that one.
in this
Yeah.
data set. Yeah.
I see. Okay, well, I think that's a good place to stop. I think we're running out of time. I want to thank Dr. Pascal Zinn, our guest author, and then our guest faculty, Dr. Nader Pouratian, for joining us for this. I would just like to remind everyone that this podcast activity is available to claim for 1.5 CME and is complimentary to all CNS members through the online education catalog. I want to thank you all for tuning in, and we hope that you'll join us for the next Journal Club podcast.